the first of the several tutorials that I want to prepare for the problem chapter 14. I did this thing in the lab on Friday, and I was going to do it using no planes of symmetry as is exactly in chapter, as done exactly in chapter 14. Okay, and then repeat the same problem where I take the two planes of symmetry that are applicable here, and but I didn't have a chance to do that. So the first segment is this first tutorial is going to be on no planes of symmetry, exactly like it's done in the book. Okay, just now the situation is this: we have a block here. We have a block with two holes, and these pins are inserted into it symmetrically. The ends of this pin, the bottom pin, the ends of the bottom pin are clamped somehow, the end faces, and the side faces of the top pin are pushed up by some amount. I believe it's 0.01 inch. Okay, so no planes of symmetry. I'm going to create all three parts one by one. They're very simple. So let's start with where's that Catia? Right there. Immediately save this product. So file, save management, save as, desktop, new folder. Chapter 14, no symmetry. No symmetry. All right, let's make it. Let us insert the first part, which is going to be our block. So first I'm going to switch to assembly design. Okay, we are in assembly design in a second, right there. So insert new part in there. And I'm going to call this thing the block. Right click properties, block, and block. All right, let's do it. So let's go in this part and make a geometry which looks similar to what's in that chapter, whatever it is, chapter 14, I believe. Okay, so I'm going to make this thing nice and symmetric because eventually I want to come down and cut this thing. Okay, so here we have this, and then we have a circle up there. We're going to dimension these things in a minute. Okay, and the easy way to create a circle of the same size down here, I will actually use symmetry. Where's the symmetry icon? Okay, so symmetry icon. Oh, actually, so right here, mirror. That guy with respect to this axis. So it's going to be down there. Let's do some dimensions. So this top, according to the book, the dimension of this top rectangle is, if I'm not mistaken, 4. This is 4. Okay. The side, according to the book, it is 10 inches. The radius, diameter is 1. Okay, and the distance from the center of this circle to the axis is 4 inches. So these are exact same dimensions that I've used in the book. Okay, good. Exit. Palette in both directions. Now this is surface design, so you've got to go part design if you're going to create solid objects. Part design, so pad this, mirror extent, and since the total is to be 1 inch, so we make it 0.5 in each directions. Good. So that takes care of this particular geometry. Now we're going to insert the second part. Insert, new part. Yeah, insert new part in there. Always say no. So this is going to be top pin. Right click properties, top pin, and the part this was the part instance name, and the part name is top pin. All right, let's do it. Get into part design. On a convenient plane, on that vertical plane, I will sketch. Why don't I project that circle to make my job easier? Okay, exit and pad it. Mirror extent. And total length of the pin, I believe it is 3, if I'm not mistaken. So we pad it in 1.5 in each direction. 1.5. Now notice that I'm not creating any assembly constraints, but the way I'm creating this assembly is right as far as the configuration is concerned. But if I ever have to move these parts, then I'm in trouble because I don't have any assembly constraints. Okay, so let's do another one. Go back to part design, insert another part. Say no. Call this thing bottom pin. Right click properties. Bottom pin. Could you repeat the same process? I could have copied it and pasted it, or used an existing component after saving, but I decided to go ahead and make it bottom pin. I did mention in class why is it that this may not be good strategy, or copy is not going to be copy paste is not going to be strategy, but I'm not going to worry about it because we already discussed it. So on this convenient plane, I will sketch. Again, project that circle. Exit. Pad it in both directions. Mirror extent. 1.5. Excellent. Everything is made out of steel, so I go to the assembly level and click on the part or apply material. Everything is made of the same thing, therefore I can apply to assembly and parts are going to inherit it. Otherwise you're going to have to do this thing one by one depending on how the parts are made. What are they made of? Okay, so let me collapse these branches of the tree. Save everything. I don't know whether I did it or not. It looks like I have. Okay, good. So now we're going to go to generative structure analysis. Generative structure analysis, right there. Catia immediately sees 3 parts and is going to mesh it. And the size of the mesh for each one of them depends on the size of the parts. Now, I did mention in class that it's a good idea to have a smaller, a finer mesh around the top hole and the bottom hole. But this is not in the book. This particular aspect is not in the book. It's in a different chapter. You did a tutorial for it 2-3 weeks ago. But anyway, so let me do that. So let me first of all change this thing to the standard default drawing color. Okay. So now I'm going to you know, the model manager toolbar, the second icon, second sub toolbar, in the middle it says local mesh size. Local mesh size, and it does nothing because it's expected to say which one of these 3 elements do you want to refine. So obviously it's the block that I want to refine, and then it says where do you want to refine it. Okay, I want it around that hole, so let me hide this pin, and hide this pin, and select, not that edge, sorry, select, cancel that. Oh, one face, okay, very good. And that face, I want to refine around that face, and the default size that suggested to me is 0.3. In fact, if you zoom in, you can see what 0.3 is. 0.3 is roughly that size. So let me actually make this thing, I don't know, make it a little bit smaller, 0.2, so that you can see actually what happened. You see that? It got smaller, okay? And you can even make it even smaller if you want, so for example 0.1, so that we can actually see it distinctly. Right there, you can see this 0.1, and this right there, this is 0.1. And I just noticed something, and that is inadvertently when I did it, I selected that edge too. So I don't want that edge to be part of what I have. 2 faces only, right there. Okay, so actually let me delete this because I think I accidentally touched something, and so here we are. So it's this one that I want to refine. It's that surface. Accidentally I selected the edge the first time that I did it, and then also the surface, and the number is the same. Okay, good. So if you want to actually, let me bring the pin in the front so that you can see how it compares to the pins. Okay, so let's look at the mesh. Right click, where are we? Right click, mesh visualization. All right, you can see that the size of the elements around the hole are smaller than the default size. Okay, I didn't do anything with the size of the top pin and the bottom pin. They were small to begin with. They're going to stay small. Okay, so that's good. Why don't we save the analysis file? File, save management, the analysis file, which is right there. Put it in the same folder. Excellent. Now let's deactivate the mesh, and we move on with the problems that we did in before. All right, so clamp this edge and that edge. These ends are clamped. Okay, very good. Okay. Now I want this thing to be pushed up by 100th of an inch. So the first thing I have to do, I'm going to make it going up by 0. So in the direction up, these two faces, in the Z direction, and now I can go and change it. So select the enforce displacement on that restraint that I made. This restraint that I made is, let me see now, where is the restraint? Let me cancel this thing for a second. Alright. Where's my tree? Right there. Okay, so the restraint that I made, you can pick it from the screen or you can pick it from the tree. It's up to you. Like that. So enforce displacement for this in the upward direction, 0.01 inches. Now, I'm going to retrace all the steps that I made to eventually solve the problem. This is not going to run. If I run it, you'll see why it's going to crash in a minute. I'm going to take all the steps which are not going to work until the final one of the problem, right there. Now, if you try to plot the deformation and animate it, you will see that the pin has no idea that there is a block there. It just goes through it, okay? And the other way around, the block doesn't know. That's because it's not properly restrained. So we have to fix it now. All right, to fix these things, we have discussed started discussing the process about 10 days ago. And so we have to create connections. So we go and create a connection, analysis connection toolbar right there. This is a very important one. Okay, so what we do is this. The first component is the surface of the pin, and then I hide it. And for the second component, surface of the hole. Okay, and I'm going to call this thing top pin. Top connection, how about that? Top connection, so that I know what I'm doing. There may be several connections, you have to know what they are. Top connection. Okay, good. And I repeat this thing for the bottom one. So analysis connection, I'll call this thing bottom connection. Bottom connection, first component, surface of the pin, and then you hide it. Second component, surface of the hole. Okay, and these connections that you create are all also showing up in the tree. So connection 1 and connection top connection, bottom connection. Also, there's these little there are these little dots that are created. Let me bring this in the front. Let me bring that thing into show mode. Okay, so let me see for a second. There are these little dots, white dots here that are created. So let me hide this mesh. See that? That dot, that's the connection, top connection. You can access it from here or from there. And the same thing is going to be down there. If I hide this, if I hide that, you see that the connection is also created on the screen. This little white dot, you can do that. But anyway, just leave it the way it is. As a matter of fact, I don't need any of these things, so I'm going to hide them. I don't want them to be cluttering my screen. Okay, then these connections that I created, if I say they're fastened, go to the connection properties right there. The first toolbar right there. It says if well, you have a choice of sec. If you select the third one, it says fasten. Fasten means that as if these two pieces, the pin and the hole of the block, were glued together or welded together. If that is not the case, in other words, they're not glued together or welded together, they're just inserted so that they can establish contact between them, and there may be gaps developing after loading, then you call it contact. So contact, this is the second one from the left, this is going to be contact, and also the bottom one is going to be contact. Do not fool around, please do not fool around with friction ratio or no sliding and clearance, because you have no idea what it is. Even though you may be getting good looking garbage, I will not accept that on the exam. Okay? Alright. Now, save everything. We're going to run it again. We'll see that it failed, except that there will be no penetration involved. There will be rigid body motion, but the pin will not penetrate the block, or the other way around. Neither one of them. And then, of course, we have to fix it. Find out what went wrong and fix it. It will bomb out. You'll see. Notice that it does take a while because the problem is essentially anything involving contact makes it non-linear. It has to do iteratively, and we took a very fine mesh around the hole and the hole of the block and the pin. Look at this, by the way. Inadvertently, I may have selected quadratic element, and this is a gigantic number. It will run, but you can see that the time, CPU time, is 2,000 seconds. So, oh my God, this may take a while. I may have to kill this and actually change element type. Now, the good thing is that I saved it. If I have to kill it, then at least things don't have to be repeated. Let's just give it a couple more minutes and see how it works. In all likelihood, I have parabolic elements. Small mesh, contact, parabolic elements is a triple whammy. And then I have a computer which is about 8 years old, and that by itself is a problem. Okay, so yeah, here. It didn't run. Let's see why, and then I'll make sure that I change the element type to linear. Okay, so deformation, animation, where's the animation? Right here. Let me make the scale bigger. Where's the scale here? Scale default, bigger, okay. And now you can see what happens. You can see that the pin does not penetrate the block, but it can slide in there. Okay? Alright. So let me stop this. First of all, make sure my elements are in fact linear. Yep, you see, it was parabolic. And same thing down here, parabolic. This is why on the test we'll tell you, unless otherwise instructed, you're asked to use linear element size, default element size, and linear type. Okay, so why is this happening? Because this pin has no flexibility, has no resistance, has no stiffness, not flexibility, has no restraint in this direction. So I'm going to create a restraint here. I'll call this thing movement, lateral movement, and so this face and the back face of the pin cannot move in the direction X. This is to avoid that rigid body motion. Direction X is direction 1. And we say OK, and you will see that this will not work either. Well, solve some problem, but it will not work entirely. So let's run it. I should have saved this thing. Where's the save here? Save. This is in case I have to stop it. Then at least we don't lose any of the stuff that we have done so far. Okay, this will be fast. By the way, look, from 2000 it went to 20 because of the linear type. And let's run it and watch that it miserably fails. Okay, let's see what happened now. So plot the deformation and animate it. This time, the block, nothing stops the block from moving. Okay, so we're going to fix this. We're almost done, not quite. Deactivate. Another restraint. This one I'm going to call block movement, block lateral movement, block lateral movement. Okay, and I will stop the block. One corner point, just one corner point. It doesn't matter which corner point of the block, prevent it to move in the X direction, direction 1. And run it, and it will see this is the last failure. We'll see that it fails once again, and we have to fix that, and it's not going to be hard to do. Okay, now deformation and animate. You can see the pin and the block do not move in the direction X because we stopped it. But there's nothing that stops the pin in moving in direction Y. Okay, so all we have to do is to go and fix the Y direction movement, and I can do that in this pin lateral movement. Not only do not move in X, but do not move in Y. And now save and run, and it will work. This time it will work, and I made sure that I did all the things that can go wrong before jumping into the conclusion, showing you what will work. I mean, that's the way it's done mostly in the book. But there we are. This time it worked. So look at the deflection, change to the default scale, and there we are. And you animate it. Right there, you can see that. Yeah? You can see that. Now, unfortunately, this computer of mine won't allow you to plot the contours properly. This one is okay, but when I change it to material shading, oh, this one works. Okay, linear works. I don't know. So that one works. Stress works. Let's see if deflection works. Let me see now. Oh, I guess that one works too. Sometimes it works, sometimes it doesn't. So anyway, you can see this is the deflection. The biggest deflection is on the top portion. The bottom is, of course, mostly fixed. And let me see now the stress. Let's look at the stress one more time. Let me deactivate that. Activate this. The stress is PSI, 90,000 PSI. That's a huge stress. Oh no, 9,000. Sorry, 9,000. Oh no, 90,000 psi. That is a big stress. In fact, material, unless it's a high strength steel, it will yield for sure in places where that happens. Now, yeah, so I'm not going to get into more details of this. I will repeat this problem using planes, the planes of symmetry. Notice that in the present problem, if you look at coordinate system here, let me deactivate this. If you look at the coordinate system, YZ is a plane of symmetry, XZ is a plane of symmetry, but XY strictly is not. XY is not the plane of symmetry. The middle plane is not the plane of symmetry. Because, on the other hand, if, for example, instead of clamping these two endpoints, I push the ends of these end faces of this bottom pin down by the same amount as the one on the top, then XY becomes a plane of symmetry, and there will be 3 planes of symmetry. So the next one is actually going to be exactly the problem that we are doing, but with 2 planes of symmetry. Okay, now before I do that, let me remind you that I don't have to because I'm going to cut these things, but I want to save all of these results. So I want to store my geometry into a different folder. So I go like this: File, Save Management. Now product, see that product file right there? I say Save As. I take it to the desktop, a new folder. This time I say with 2 planes of symmetry. Okay, with 2 planes of symmetry. So I just want to create, and propagate directory. When you say propagate directory, so anything that goes with that, including the parts, are going to go in there. So propagate directory. I'm not sure whether I actually put it in the right spot or not. I may have to come back and fix this thing because I lost track of what I was doing. So let me see what happened here. Here, with 2 planes of symmetry. Okay, this chapter 14 with no planes of symmetry. Yeah, right. This is what happened. So your product went there and the parts went there, and these are not related to the stuff that was in the earlier folder, because I say propagate directly. They're standalone. If you make changes here, they will not affect the previous folder, or if you make changes in the previous folder, it will not affect this. So I will stop the video clip here and I'll start at this point. Just to make sure that is the case, let me do the following. Let me go here. Let me close this and close that. So I close this, or I'll leave it open. Let me start with product here in the new folder, and then I can start cutting it. In the second segment, I'm going to start cutting these things. Alright guys, take care.